Hello friends, today I have brought for you 10 questions that were previously asked in the board exam of CBSE class 12th. These questions are from integration. Even if you are an ICSE student or from any other board, these questions will be helpful to you. So I recommend you that you solve along. In fact, whenever I start a new question, you should pause the video and try and solve the question yourself. Once you have solved it, you should see the answer. In case you are unable to solve it, then also you should see the answer. So we'll start with the first question, which you can see on the screen. This was asked for 2 marks. In this question, they have given dx upon x square minus 6x plus 13. So this is a quadratic function. This is a rational function in which the denominator is a quadratic function. So what will we do? We'll try and convert it in the form 1 upon x square plus a square. Integration of 1 upon x square plus a square. For that we have a direct formula. So with that in mind, let us do the completing the square method over here. So we'll write integration dx x square. Now see, we have 2ab is equal to 6x. Okay. Now 2 is there. For x we have x and b is equal to 6x. We have to find the value of b. So this will cancel out and this will be left with 3. So b is equal to 3. So we can write minus 2 into 3 into x plus 3 square is 9. Out of this 13 we have taken out 9, so we are left with 4. So this formula will become dx upon x minus 3 whole square. This is a square minus 2ab plus b square plus 2 whole square is 4. Now what can we say? We can say let x minus 3 is equal to t. So that will give me 1 dt by dx when I will differentiate it. So that will give me dx is equal to dt. So I will put it over here. So I will get dt upon t square minus 2 square. Sorry, t square plus 2 square. Okay. Now once I reach here, I will use a formula. The formula is 1 upon x square plus a square dx. 1 upon x square plus a square dx. That will become 1 upon a tan inverse x upon a plus c. So here you can see this will become 1 upon 2 tan inverse t upon 2 plus c. I can write 1 upon 2 tan inverse. For t we can write x minus 3 upon 2 plus c. And this will be our answer. This is our integration I. This is the answer. Okay. So you can see in this question what have we done? First we have used completing the square method to convert it in the form 1 upon x square plus a square, and then we have used this formula. This is a simple question for 2 marks. Okay. Now let's move on to the next question. Here you can see this has some trigonometric functions. Now see, we are getting here cos x dx. So we will get cos theta d theta. We will get this when we will differentiate sin theta. So the hint is that we should take sin theta is equal to t. So all the other functions should be in sin theta. But here we have a function, here we have cos square theta. So we will first try and convert this cos square theta into sin theta. For this what we will do? We will take 3 sin theta minus 2 cos theta. For denominator we will write 5 minus 1 minus sin square theta minus 4 sin theta d theta. Now here we will take let sin theta is equal to t. So it will be, when we will differentiate, we will get cos theta is equal to dt by d theta, and cos theta d theta will become dt. This will become dt. So what will I do? I will do 3t minus 2 upon 5 minus 1 will become 4. 4 plus sine square theta minus 4 sine theta. Okay. Now in place of sine theta we can write t. So I will get 3t minus 2 upon t square, for sine square theta I am writing t square, minus 4t plus 4. Okay. So we are getting this. Now what we will do? We will convert it we will use the form here where we write the numerator as part of differentiation of the denominator plus some variable. So we can write, we will differentiate the denominator. We will write, here we will get dt. We will get for cos theta d theta we will get dt. This box. Okay. So what will we do now? We will write 3t minus 2 is equal to a of d by dt of t square minus 4t plus 4 plus b. So it will become 3t minus 2 is equal to 2t minus 4 plus b. Now we will write 3t minus 2 is equal to 2t, a is also here, 2ta plus b minus 4a. Okay. Now on comparing coefficients, we will see, we will get 2a is equal to 3. So this will imply that a is equal to 3 by 2. Okay. Next what we will get? We have got b minus 4a is equal to minus 2. So what we will get? B is equal to minus 4 into 3 by 2 is equal to minus 2. So we will get b minus 6 is equal to minus 2. So b will be equal to 4. So how can I write the numerator? From here we can see, I can write the numerator as, from here we can see 2t minus 4 into a. 2t minus 4 into a. What was a? 3 by 2. So we will write it outside, 3 by 2, and the denominator will be same. Denominator will be t square minus 4t plus 4 dt. And I can write down b part as, b was same, b does not have any variable on the numerator, it will write 1 t square minus 4t plus 4, and then I will write it down as dt. Now let's write this as I1 and this as I2. Now how will we solve I1? For solving I1, we will take let t square minus 4t plus 4 is equal to u. Now by design what have we done? 2t minus 4 is equal to du by dt. So 2t minus 4 dt is equal to du. So what will I get over here? See, by design we have made it as such that the differentiation of the denominator is the numerator itself. So what will we get? We will get du upon u, and this will be 3 by 2. So I will get I1 will be equal to 3 by 2 log u, where 3 by 2 log t square minus 4t plus 4. Now this is nothing but 3 by 2 log t minus 2 ka whole square. Now this will become, the square will come out, the power will come out, 3 by 2 into 2 log t minus 2. This will cancel out and we will be left with I1 is equal to 3 log t minus 2. Okay. Now let's move on to I2. What was I2? I2 is 4 integration dt upon the denominator is the same, that is t square minus 4t plus 4. So this I can write down 4 dt upon t minus 2 whole square. Okay, now I will take let t minus 2 is equal to k. This will become, we will differentiate with respect to t. This will 1 is equal to dk by dt. So dt is equal to dk. So I2 will become 4 dk upon k square. This will become nothing but minus 4 upon k. Okay, and k is nothing but minus 4 upon t minus 2. Okay, so I was what? I is equal to I1 plus I2. Now what was I1? I1 was 3 log t minus 2. 3 log t minus 2, and I2 was what? It will be minus 4 t minus 2. Now t what was there? We had substituted t as t was sine theta, if I remember correctly. T was nothing but sine theta. Okay, so we'll substitute it. This will become I is equal to 3 log sine theta minus 2 minus 4 sine theta minus 2 plus c, and this is our answer. Okay, so I hope you understood this question. Now let's move on to the next question. This is another 4 marks question. In fact, this question has been asked many times. So they keep on asking the same question again and again. Let's see how we'll solve this. What will we do? We'll do integration, and we will do, let's take it I, and we'll do sine theta upon cos theta plus cos theta upon sine theta d. Sorry, this is all in x. Why am I writing theta? Sin x upon cos x plus under root cos x upon sin x, and the whole thing is in dx. Now we'll take the numerator, we'll take the LCM of numerator, and we'll get sin x plus cos x under root sin x cos x dx. Okay, now what we will do? We will try and make this in the formula sin x minus cos x whole square. Okay, I will show you how we will do it. So what we will get? Because then we will adjust it with the numerator. That will become the numerator. It will become the if we differentiate the denominator, we will get the numerator. So that is our objective. So we will divide and multiply by root 2 sin x plus cos x upon sin x cos x root 2. Okay. So what will we do next? Next we will write root 2 sin x plus cos x, and we will add and subtract by 1. We will add and subtract by 1. 1 plus minus 1 plus sin x cos x and 2. Okay, here these are different root 2's, this is different. So now the root 2 will come inside this root 2. So we'll get this. Now you can see what are we doing here. We will write it like that. We will write it down like this: sin x plus cos x under root 1 minus 1 minus 2 sin x cos x, and everywhere we have dx, dx and dx. Then what we will do? We will write 1 as, we can write 1 as sin x plus cos x under root 1 minus sin square x plus cos square x minus 2 sin x cos x. This is all in the under root, and then we have dx. Now see, this is a square plus b square minus 2ab. Okay, this is a square plus b square minus 2ab. So instead of this, what can I write? I can write a minus b whole square. I can write sin x plus cos x under root. I can write 1 minus sin x minus cos x whole square dx. Now see, I will take let sin x minus cos x is equal to t. So I will get cos x plus sin x dt by dx, and it will be sin x plus cos x dx is equal to dt. Instead of all of this, I can simply write dt. What can I write? Integration under root 2 dt, and this will become under root 1 minus t square. Now under root 1 minus t square is the direct, for that we have direct integration formula of under root 2 sin inverse t, okay, plus c we will get, and t is what? T is sin t minus cos t, so we will get under root 2 sin inverse sin t minus cos t plus c. Sorry, sin x minus cos x. T is sin x minus cos x plus c. Okay. So I hope you got this question. I is equal to under root 2 sin inverse sin x minus cos x plus c. Okay. Now let's move on to the next question, the fourth question. Now see, in this fourth question we can see that this is a fraction and we will be using partial fractions over here. We will be using partial fractions over here. See, one thing, until now we are doing substitution, but here we will just change the name. We will denote x square by t. We will say let x, sorry, not let, sorry. We will be denoting it by, we will say put x square is equal to t, and see, we will not be using the integration formula until we get the partial fraction. At the moment we will only get t plus 1 upon t plus 4, okay, t plus 1 upon t plus 4 upon t plus 3 upon t minus 5. Once I multiply them, I will get t square plus 5t plus 4, and denominator will be t plus 3 and t minus 5. In fact, denominator will be t square minus 2t minus 15. Okay, now what can we see? We can see that the degree of both the numerator and the denominator is the same. Now we cannot use partial fraction until the degree of the numerator is less than the degree of the denominator. So what we will do, we will divide over here. We will divide like you used to do in small classes, t square plus 5t plus 4. What will we do? T square minus 2t minus 15, 1 ja. What will I get? T square minus 2t minus 15 minus plus minus. This will cancel out. What will I get? I will get 7t, and this will become plus, sorry, and become plus 19. So I can write it down as a mixed fraction as 1 plus, because the quotient was 1, I can write it down 1 plus 70 plus 19 upon, I will not write t square minus 2t minus 15 as denominator. I will write t plus 3 and t minus 5. Now I will try, now see, now here I have t square minus 19 upon t minus 2, t minus 5. Now the denominator has a degree 2 and the numerator has a degree 1. So here I will apply partial fractions, okay? So I will do 7t plus 19 upon t plus 3, t minus 5. I can write it down as a upon t plus 3 plus b upon t minus 5. This I will write down as 70 plus 19 is equal to a t minus 5 plus b t plus 3. When t is equal to 5 I will put. So what will I get? 7 5 is 35 plus 19 is equal to, this will become a into 0 and b will become 5 plus 3 8. And what will I get here? 45 54 is equal to 8b. So b will be equal to 54 upon 8, and when I cancel it out I will get b is equal to 27 upon 4. Okay. Similarly, I will put t is equal to minus 3 over here. When t is equal to minus 3, what will I get? 7 into minus 3 plus 19. 7 into minus 3 plus 19 is equal to a into minus 3 minus 5 plus b into 0, because minus 3 plus 3 will become 0. So what will I get here? 7 3 is a minus 21 plus 19 is equal to minus 8a plus 0. So this will become minus 2 is equal to minus 8a. So this will become a is equal to 1 by 4. So how can I write this? I can write 70 minus 19 upon 70 minus 19 upon t plus 3 t minus 5. Let me see if I remember this correctly. T plus 3 t minus 5 is equal to, a was 1 by 4 into 1 upon t plus 3 and b was how much? Plus b was 27 upon 4. 27 upon 4. 27 upon 4. Yes, and denominator was t minus 5. 1 upon t minus 5. So this I have got for this fraction. Now see, now what I will do, now I will put this back into the integration. I will again use x square. I will not be substituting x square is equal to t. Okay, now I can write this all in place of integration. Our integration was x square plus 1 upon x square plus 1 into x square plus 4. And then what was there? X square plus 3, x square minus 5, x square plus 3, x square minus 5, and this we broke down as 1 plus, we have 1 plus, see we have 1 from here, and then this thing we broke down as, 1 upon 4, 1 upon x square plus 3 plus 27 upon 4, 1 upon x square minus 5. This is dx. Okay, this is our integration. So now we will solve it. We will say take it into different differentiations. So if I take this as I can write it down as dx plus 1 by 4 upon x square plus 3 dx plus 1 by 4, 27 by 4, 1 upon x square minus 5 dx. Okay, so the first part is simply x if we integrate it. Let us call this I1 and let us call this I2. So I1 is what? I1 I can write down. I1 I can write down 1 upon 4, 1 upon x square plus under root 3 whole square dx. Now we will be using the same formula that we used previously. 1 upon x square plus a square is equal to 1 upon a tan inverse x upon a. So what do I get here? I get I1 is equal to 1 upon 4. 1 upon a is also there, into 1 upon a tan inverse x upon root 3. Okay, now what will be I2? I2 is 27 upon 4, 27 upon 4 integration 1 upon x square minus 5, integration 1 upon x square minus 5 dx. So what will we do? We will do let x square, for formula is 1 upon x square minus a square dx is equal to 1 upon 2a ln x minus a x plus a. Okay, so I will use this formula. So the whole integration I will get I is equal to, first integration, this will become x, then the second part was 1 upon 4 root 3 tan inverse x upon a, and the last part would be 1 upon 2a. 2a will be, we have 27 upon, not a, x upon under root 3, and the last part would be 27 upon 4, and then it will be 1 upon, this will be root 5, 2 root 5, and it will be log, or ln, we can write ln x minus root 5 upon x plus root 5 plus c. This will be our answer. Okay, this will be our answer. This was a little lengthy, but I hope you understood it. Okay, students. Now let's move on to the next question, that is question number 5. See, in question number 5, what we will do? We will again try and write the numerator as a part of the some differentiation of denominator, and then we'll try and do it. So first let us multiply the denominator and see what do we get. This is a 6 marks question, so this is supposed to be a lengthy question. 6x plus 7 upon under root x square minus 9x plus 20. So now what we'll try and write down? We'll write down as let 6x plus 7 is equal to, now the differentiation of denominator is 2x minus 9 and a plus b. Okay, so now we'll write the coefficients together. 6x plus 7 is equal to 2ax plus b minus 9a. So this will be what? 2a is equal to 6, that means a will be equal to 3, and I will write b minus 9a is equal to 7, and b 9 3 is 27 is equal to 7, so b is equal to 34. Okay, so I hope you got this. Now what we'll write down, we can write the numerator as 6x minus 7, we can write it. A is what? 3 times 2x minus 9, and then we will write down integration of x square minus 9x minus 20, and we can write the other one as, this will be dx. We will write the other one as b was 34. So 34 upon dx 34 under root x square minus 9x plus 20. This is also plus 20. Okay. Now we'll take this as I1 and we'll take this as I2. Okay. So in I1 what we will do? Let x square minus 9x plus 20 is equal to t. X square 2x minus 9, it will become dt, or here we will get dx. So here instead of whole of this, what will we write? We will write dt. 3 dt upon under root t. Okay, this is the I1, for we are solving for I1 only. So when we are solving for only I1, what will I get? This is t की power minus half dt 3. What will we get? We will get 3 t की power half, and this will get 1 into 2 plus c. Or we can simply write it down as I1 is equal to, that is I1 is equal to 6 times under root of x square minus 9x plus 20. Okay, plus c. Now we will take I2. What is I2? I2 is only that the numerator is 34 and the denominator is same. So I2 is 34 upon x square minus 9x plus 20. X square minus 9x plus 20 is I2 dx. Now what we will do? We will try and convert it into the formula. We will try and convert it into the formula. We have direct formula for under root x square minus a square. Under root x square minus a square, we have direct formula. So we will try and apply that. For that we will have to use completing the square again. So this time what will be? You can see 2ab is minus 9x. So 2 into a into x is equal to 9x. Minus is not important over here. So x will get, so a will be 9 by 2. So I can write I2 as integration of 34 and then x square minus 9x plus 81 by 4 minus 81 by 4 plus 20. Here is under root till over here. Okay. So I2 will become 34 upon under root x minus 9 by 2 whole square, and this will become 80 minus 1 upon 2 ka whole square. Okay. So what can I write over here? Here I will use the formula. See, as long as the coefficient of x is 1 and the power of x is 1, we can directly use the formulas. The formula is integration 1 upon under root x square minus a square is equal to dx is equal to ln x plus under root x square minus a square plus c. So I2 will become, this is dx, I2 will become 34 ln x, we have x minus 9 by 2 plus under root. Now the whole thing is x square minus 9x plus 20. X square minus 9x plus 20 plus c. Okay. This is I2. Now what is I? I is equal to I1 plus I2. I is what? 6 plus under root x square minus 9x plus 20. 6 under root x square minus 9x plus 20. x square minus 9x plus 20 plus 34 ln x minus 9 by 2 plus under root x square minus 9x plus 20 plus c. This is the answer. So I hope you understood it. We have used this formula over here. You have to learn all this formula. In fact, I will give you a link in the description where all these formulas are there for a web page, for a link. Okay. Now let's move on to the next question. In the next question, they are given x square. In the next question, they are given x square plus 1 e ki power x upon x plus 1 whole square dx. Now see, whenever they are given e ki power x, we will try and use the form integration e ki power x fx plus f dash x dx is directly e ki power x fx plus c. You can use this formula directly, okay? So we'll try and convert this part into fx plus f dash x. That is the function plus its derivative. Okay. This formula that I gave you here, you get from by parts. Yes, from by parts. So let's solve it. I am also a little tired, but we will still go on. X square plus 1. In case you are tired, pause this video, go have some water, and then come again, start this video. But don't leave it in between and don't come. That is bad. You can take a break. Okay, so I have written it like this. Why am I writing this again? I will write it like this in the next step. Yes, I will write it like this. X square minus 1 plus 2 upon x plus 1 whole square. Now this is a little adjustment that we are doing to convert it into this form. So what will I get? I will get x square minus 1 x plus 1 whole square plus 2 upon x plus 1 whole square dx. Now see, this is a square minus b square. So what will I get? X minus 1 upon x plus 1 x minus 1 upon x plus 1, okay, and there I will get 2 x plus 1 whole square, and I forgot to write it down over here, e ki power x. The whole thing is with e ki power x dx. Now you should have the foresight to look over here that if I differentiate this, if I take it as fx is equal to x minus 1 upon x plus 1, and I differentiate it, that is f dash x. I will use quotient rule over here, and I differentiate this, I will get 1 x plus 1 minus x minus 1, and there I will get 1 upon x plus 1 whole square. So what will I get? X plus 1 minus x plus 1 upon x plus 1 whole square. X will cancel, and I will get 2 upon x plus 1 whole square. So I can clearly see what? That I got this. So this is fx and this is f dash x. So in the next step, I can directly write down e ki power x. What was fx? Fx was this. X plus 1, x minus 1 upon x plus 1 plus c. This is my answer. I hope you understood it. Okay. This formula is very important. This formula over here, we use this formula. This formula often comes in the exam. This often comes in your very competitive exams. So whenever you see e ki power x multiplied by some number, multiplied by some function, you should try and convert it into this formula. Now let's move on to the next question. In this question, we can see that cos inverse x has a derivative minus 1 upon under root 1 minus x square. So this is somewhat like that. So we'll first use substitution. Let cos inverse x is equal to t. So what will this become? Minus 1 upon under root 1 minus x square is equal to dt by dx. So what will it get? It will get minus, in fact we'll get dx upon 1 minus x square is equal to minus dt. Dx under root 1 minus x square is minus dt. So we'll substitute this, and from here we can also get x is equal to cos t. So in place of x we'll write cos t. Okay, cos inverse x is t, and this whole thing is minus dt. So minus will come outside and we'll write dt over here. Now here we'll apply by parts. Okay, we will apply isolate. Isolate is just a thing to remember it, but it is called by parts. So the by parts, the formula for by parts is uv dx is equal to u v dx minus du by dx v dx and whole by dx. So here we'll use isolate to see which is the u function and which is the v function. So algebraic comes first. Okay, algebraic comes first. So we'll take u is equal to t and v is equal to cos t. So we'll do du by dt. Here we don't have x, so we'll do du by dt is equal to 1, and integration v dt is sin t. So minus cos t dt will become minus of u is what? T sin t minus du by dx is 1 sin t dt. So what will I get over here? Minus t is nothing but, what is t? T from here is cos inverse x. T is nothing but cos inverse x sin we have sin t. Let's write it down as sin t at the moment, and we can write this. In fact, we didn't even do this. We'll write it plus cos t dt. Okay. Next, what we will do? We will first try and convert it into minus and cos inverse x sin t I can write down under root 1 minus cos square t. Cos t is nothing but x. We can see from here, this will go. Cos t is nothing but x. Okay. So this will become minus cos inverse under root 1 minus x square plus x plus c. This is your answer. This was also comparatively shorter question. Okay. So I hope you understood it. Now let's look at this question. This is a pretty tricky question. Log x plus 1 upon log x whole square. So carefully look at it. So in this we'll start with let log x is equal to t. So if you remember log properly, it will be e की power t. Now if I differentiate it, I will get dx is equal to e की power t dt. E की power t dt. Now what will we get? We will get integration of, if I substitute all this, I will get integration of log t plus 1 upon t square. Instead of dx, I will get e की power t dt. Okay. So what will be this? I will subtract and add by 1 by t. Okay. Now, if you don't know this trick, it will be very difficult to solve this question. Only if most of the students wouldn't have been able to solve it if they don't know this trick, or the method would have been too long. Now you can see again, this is what? Fx. And this is what? F dash x. I will show it to you. If I say fx is equal to log t minus 1 by t, and if I differentiate it, f dash x, what will be to be 1 upon t plus 1 upon t square. This is f dash x. Okay, so if I take this as I, so what will my I be? My I will be e की power x fx. Now fx is log of t minus 1 by t plus c. Okay, now sorry, log e, it is x is, this is e की power t, so I will rub this is e की power t. So I is what? E की power t is what? X, and t is what? Log x minus 1 upon log x plus c. Now this question was pretty short, but this is a tricky one. Okay, I think you should see it again. First we took log x is equal to t, then we substituted it as x is equal to e की power x dx. Then we used we subtracted and added minus 1 by t, and then we used it in the formula fx is equal to e की power x fx plus f dash x is equal to e की power x fx. Okay, now let's move on to the next question. Question number 9. This is also a 6 marks question, and this is also a pretty lengthy question. So in this question, how will we start? In this question, we will first use the properties of logarithm, and we'll write I is equal to integration x square plus 1 and log, this is log a minus b. This power will go over here, x square, and I can write it down as x square plus 1 upon x square upon x की power 4. Okay, whole upon x की power 4, not just log but the whole thing. Now we'll do let x square plus 1 upon x square is equal to t. Okay, now we will not differentiate anything, but if we simply do some algebra and try and write the whole thing as x square is equal to something, t into x square. So what will this become? This will become t x square minus x square 1, x square is equal to 1 upon t minus what? Now if I differentiate this, what will I get? 2x dx is equal to minus 1 upon t minus 1 whole square dt. Okay, so this is what I will get. Now what I can do? I can take this as dx is equal to minus 1 upon 2x. Okay, I can take it 2x, and I can write this down as t minus 1 whole square dt. Now I can write dx as minus dt, and I can write this x as, from x I can write from here t minus 1. Now the power will go over here and it will become 2 t minus 1 3 by 2. That is half 2 minus half. This will be x is what? This implies x is equal to under root t minus 1. From here we are substituting this. Okay, now what I can do? I can simply substitute these values in the function. I can simply substitute these values in the function. Let's see what all do I have. I have x square plus 1. First thing I have is x square plus 1. Let us see what I can get. What I can get for x square plus 1. Under root x square plus 1. If I substitute, I will get under root 1 upon t minus 1 plus 1. And this will be equal to under root t upon t minus 1. We have not yet started on the integration. We are simply simplifying the function. Okay, now if I write this down, from here, now let us start from here. I will just substitute these values. Now I is equal to, first is under root x square plus 1. For that we have written down under root t minus 1. The next part is log this. Now for this whole part, we can write down log t. We can write down log t. And for x की power 4, from here what we can write down? X की power 4 is in denominator, so we can write 1 upon t minus 1 का whole square. And for dx, I can write down for dx is also here. What can I write down? Minus, integration sign will be there, minus 1 dt upon 2 t minus 1 की power 3/2. Now see, here the power of t minus 1 is half, and here the power of t minus 1 is 3/2. Half plus 3/2 will give me 2. And here t minus 1 is 2. So this will cancel out, this will cancel out, this will cancel out. I will get a very simple looking formula. Minus half I will take outside. I will get under root t log t. So with proper substitution, you will get this. Once we get this, we will apply by parts. We will take under root t as, is equal to v, and we will take log t is equal to u. We did this using ILATE. See, logarithmic comes here and algebraic comes here. So u and v. First we will take ILATE, so logarithmic will get u, and so we will do integration under root t dt, and this integration will be v dt. So this will be what? T की power 3/2, 3 upon 2. Okay, this will be v dt, and this will be what? Du by dt will be 1 by t. Du by dt will be 1 by t. So I will be what? Minus half u v dv. That will be log t 2/3 t की power 3/2. That is integration v dv. Okay, minus 1 by t and 2/3 again t की power 3/2 dt. Okay, now when we do this further, I will get I is equal to minus, I can take 2/3 common, minus 2/3, and I will get t की power 3/2 log t minus t की power half dt. This will cancel out. This will become minus 1/3. This will become t की power 3/2 log t minus, this will again become 2/3. We did the same integration, 3/2 plus c. Now instead of t, we can use x square plus 1 from here, x square plus 1 upon x square. So this will become minus 1/3 x square plus 1 upon x square 3/2 log x square plus 1 by x square minus 2/3 x square plus 1 by x square 3/2 plus c. Okay, so I hope you understood this. This question was also a little tricky. I have found the questions for you which you need help with. The easier questions you can solve yourself. Okay, now we are left with the last question, that is the 10th question. If I remember correctly, this one was asked in 2022. This is a 4 marks question, and here also you can see this is a partial fraction. This is a partial fraction question. We will again use put. We will not substitute x square, we will just denote x square by t. So we will say put x square is equal to t. Okay, so we will write t upon t square plus 1 and 3t square, 3t, oh sorry, I did it wrong, t plus 1 and 3t plus 4, and this we'll write as a upon t plus 1 plus b upon 3t plus 4. So we can write t is equal to a 3t plus 4 plus b t minus 1. So t is equal to 3a plus b t plus 4a minus b plus 4a plus b. Now we'll do comparing coefficients. Comparing coefficients, 3a plus b is equal to 1, and we'll get 4a plus b is equal to 0. 4a plus b is equal to 0. Now we'll subtract them. So what will I get? A is equal to minus a is equal to 1. That means a is equal to minus 1. Now if I put a is equal to minus 1, I'll get minus 3 plus b is equal to 1. B will be equal to minus a, I'm lost, minus a plus b is equal to 1. So we get minus 3 plus b is equal to 1. So b is equal to 4. Okay. What will we get? We will get b is equal to 4. Now when we solve it, b is equal to 4. B is equal to 4. Now when we will solve it, we will get I is equal to a is minus half, a is minus 1. So I can write I is equal to 3t plus 4. A is minus 1, 3t plus 4. A is upon, a will you substitute a over here, that is t plus 1. Okay, and that is t is what? X square plus 1. This will become x square plus 1 dx, and the next one will become plus 4 dx upon 3t. T is x square, 3x square plus 4. Now both of these are in the form, I can write I is equal to minus 1 upon x square plus 1 dx plus 4 upon 3 dx upon x square plus 4. These are both in the form of I is equal to integration minus 1 dx upon x square plus 1 square plus 4 upon 3 dx upon x square, this is 4 by 3, 2 upon root 3 whole square. These are both in the form of, we can use the formula 1 upon x square plus a square dx is equal to 1 upon a tan inverse x by a plus c. So I can use I is equal to minus 1, I is equal to minus 1 tan inverse x plus 4 by 3, a is 2 upon under root 3, that is tan inverse under root 3 x upon a plus c. So this will become I is equal to minus tan inverse x minus 2 upon under root 3 tan inverse under root 3x upon 2 plus c. This will be our answer. This will be plus y. This will be our answer. Okay. So I hope you were able to solve these questions by yourself. Even if you are not able to solve this question, you were able to understand them. I hope you will practice also. Best of luck for your upcoming exams. Your pre-boards must be starting. Okay, students. Best of luck and enjoy your day. Thank you.